Hi, everyone. Welcome to the latest edition of Walter's World, the podcast series from Astadia. For those of you who may not know, Astadia is a worldwide systems integrator and consulting company focused on mainframe migration and modernization. And this podcast series is really designed to help organizations who are looking at alternatives to what they do on the mainframe today by bringing in industry leaders to help talk about the information that we feel would be really helpful and pertinent for people who are considering alternatives. Today, I'm especially delighted to have two of my friends from Microsoft, Jim Dugan and Jonathan Frost, both principal program managers at Microsoft, here today to talk to you. So Jim and Jonathan, thank you both very much for taking the time to be with us today.
Yeah, thanks for having us.
Yeah, thanks.
Great.
Thanks, Walter. Great to be here.
We're looking forward to it. Since I had the chance to talk to both of you, I'll just kind of, if it's okay, kind of bounce questions back and forth. And please, if I ask a question of one and the other person thinks there's something that's helpful, let's just make this as conversational as possible. Jonathan, why don't I start with you? You know, one of the things that I think would be really interesting for the audience is to understand that with the project that we recently completed at the U.S. Air Force, extremely critical mainframe migration, there were some great lessons learned and information that I think would especially be helpful to organizations in the federal space as they look at you know, what they could do with their mainframe environments. So before we start with that, though, I'd just like to know, what is it that you and Jim do at Microsoft Federal?
Yeah, thanks, Walter. So both Jim and I are part of what we call the Azure Global Engineering Group. And in this group, we are very federal focused, US federal. We also focus on international and commercial as well in terms of helping our customers who are both in the government and non-government move their legacy, what we call legacy workloads, which includes mainframes, mid-range, and other non-x86 systems into Azure. And how we do that is through helping provide pathways, education, and things like reference architectures and other guidance patterns to help move them into Azure. We also help from the end to end. And so helping with looking at the early days of trying to figure out the right pathway to when we actually have a delivery partner like yourself, Astadia, to be involved in that process and help with technical guidance and coaching along the way, all the way through the deployments. And as I mentioned about the reference architectures, that's another key part of what we do, is learning from these experiences and then documenting them into reference architectures, which we have been publishing a number of them, including one that was a genericized version of what we did for the U.S. Air Force project on the Azure Architecture Center. So we actually have a mainframe and mid-range category on the center, and that architecture is one of about 12 that we have published now, and we have more on the way. We also produce white papers, and we produce other artifacts, blog articles, other guidance. But also being part of engineering is that we like to give engineering feedback, and our goal is to make Azure the best place for legacy artifacts moving from on-prem into the cloud. And so through our work with that is we work with our other engineering cohorts, whether it's Azure networking, Azure data, Azure storage, and try to give feedback and improvements that can we find that with some of these legacy artifacts, that there are times where we need to improve or change Azure to meet the needs of our customers. And that's another key part of what we do, is to make Azure the best place possible.
It certainly makes sense. And I really commend you and the Microsoft team for providing that kind of information. For an organization that hasn't been through a move such as this, trying to have as much information available as possible is obviously critical for them. So great job on that.
Thanks.
Jim, let me turn to you for a second. Could I ask your perspective on mainframe modernization within the Federal Department of Defense and civilian agencies specifically?
Okay, sure. Thank you for the question. It's a time of incredible opportunities on both the civilian side and also on the DoD side. We've got, like for the Air Force, the Air Force was facing a huge cost of running this application. It was hosted, and so they were facing like 24 to 26 million dollars is
Great.
how much it would have cost to host this application, which is crazy. And so they actually wanted to save costs in that, and have the same capabilities. They couldn't change a lot with it, but the huge cost savings that came in, and also the more capable software that's out there, is the ability to run COBOL on a modern platform, and for it to scale, and for you not to have to change very much. And it also was, I know that at least in the Air Force side, it took I think it took 5 months before the payback period
It's
was, and that
amazing, isn't
included
it?
the whole project, and that included the cloud costs for a year. It was absolutely great. And then the ability for these applications, once they're moved over, for them to on the mainframe side, is you're limited by the box itself. And by moving over to the cloud, you're limited by what the actual cloud can give you. And you choose what the scale is. And you're, again, not having to pay for what you're not using, but you also, as you start moving more or using more and you need more scale, it's just, the scale just keeps on going.
It's just
And
there, right?
the other key thing with this is on the, that's on the DoD side. But on the civilian side is there's a huge push now with the TMF, the Technology Modernization Fund, that's out there, where civilian agencies can go out and go through the process. But basically it gives funding. They keep giving, right now there was $1 billion just given in through one of the relief funds for this Technology Modernization Fund, where civilian agencies can go out and ask for money, and they can actually fund modernization initiatives. So the time is great. It's on tmf.cio.gov is the site to just learn about the process. And that's for modernizing your applications, moving your applications along. And that's why I'm saying it's a great time to look at this. You got the tools, you got the cloud, which is scalability, and potentially you have some funding that's out there. And you also have other examples within DoD as well.
Oh, absolutely. Just having the flexibility to not just save money, but to be able to leverage new and different ways of doing things. It's an amazing time for people now who are considering alternatives to the mainframe. And I think that Air Force project is a real world example of that. Jim, let me come back to you with talking about the Air Force, the IMDS migration. What were some of the key benefits of Azure as in supporting this warfighter environment? And for those who don't know, talk about mission critical environments. This is for handling the maintenance for all the wartime aircraft, the ICBMs, being able to take advantage of newer architectures and saving of money for some of the most critical application environments out there.
Well, beyond the cost savings, there was additional capabilities that they can now take advantage of. A good example is utilizing artificial intelligence / machine learning on the data. So part of the data that they have is logistics information, part data, repair data for any of the airframes within the Air Force. Well, now you can implement things that we've been doing for several years around predictive maintenance, that this part breaks over here, then you should also replace this part over here, because we've seen in the past that they break in pairs. So instead of just doing one, you want to do both of them. So it's actually allowing you to predict, when things are going to go bad, how, based on your workload, and have that constantly adjusted. And that's just one small example, but opening really taking the database that was really siloed inside the mainframe, putting it into a cloud database, opens up a lot of those opportunities, and the Air Force can take advantage of that. Also, the benefits of fault tolerance, disaster recovery, the ability to take the environment, because if you have the environment and you want to do another dev test environment, you kind of need to have a fast way of duplicating that environment. And now they can duplicate the environment of the production system just in a couple minutes, where before they, number one, were limited by the number of environments that they could use because they were limited by the mainframe. But now they can actually copy the environment with a single script, run it, and have it running in parallel for continual development in that environment. So there's tons of other ones. I mean, we could probably just list those out for the next half hour on those, but I kind of wanted to give you two of the big ones.
And that's really critical. I think that, we talk about freeing the data and what that really allows people to do, rather than being in a siloed environment where you only have one way to look at data. Being able to leverage the technologies that you talked about, I know for the Air Force, that really put them in position to do things differently than they'd ever been able to do before. So as you say, not just cost savings, but also a new way to do business. So that's
and great. That also brings up something that's kind of ties back to the first question you brought up as to what our team does, is we're also, we by getting involved in the opportunities, by getting involved in the migrations, we're learning things too. And so we're talking with the other teams, like the AI teams or the the machine learning team, to say, hey, this customer has the data, they're sitting here, and we want to make this easier and more prolific for a legacy type customer. And that's another thing that we did to underscore from that first question.
That's a great point.
Yeah.
A question that I get asked often, as I'm sure you do, and I think it's an important one, so I'm going to ask both of you this one if you don't mind. As federal organizations look to move to Azure, how secure can they really feel that they'll achieve the same security levels that they see on the mainframe?
Yeah, so Microsoft has been focused on strong security and privacy protections for over 10 years. We had the big privacy initiatives and the trustworthy computing that went through Microsoft. And so it was really kind of burnt into our DNA about everything that we do. Is we we look at security first. We look at the differentiators or the privacy differentiators that we have inside the products themselves. And we're always looking to expand those, and we are. There's constant, if you look at the changes that Azure has gone through over several years, is it's done two things. It's also added capabilities to the products, but we've also gone after additional capabilities that the government cloud, the secret cloud, going after, different things like FedRAMP, DoD certifications, IL level, CGIS, HIPAA, and support for IRS 1075 is among it. There's tons of others. There's a lot of different compliance compliance that we're following, and that has caused, in the past has caused some changes, but we go, even further than that by enabling some different things where you didn't have in the mainframe, like the ability to audit, the ability to raise alerts, or even to tie in some level of, let's say, intrusion detection. Mm-hmm. You might, Azure's constantly watching and looking for signs of some sort of intrusion to notify somebody, and that level of intrusion could change based on the activity of the data. It could be, different variations of, the attack vectors change all the time. the cloud is constantly watching that and adjusting to those, whereas you don't have that same capability on the mainframe. You can add intrusion detection, you can add this, but you're constantly having to keep up with what it's doing, dealing with and taking advantage of things that were done in the cloud, and the ability for the cloud to learn from those. And by having the system in the cloud, you kind of get that. You get the the ability for the intrusion detection, for the different levels of auditing, for anomaly detection of the activities that are there.
And just to build on that too, Jim makes some really great points here. Is that something that I think you touched upon just a moment ago, Jim, is that how when you're on premises and you're on a mainframe system, you are in a very slow to change monolithic system. And so as the world changes and as intrusion methods change, as security models need to become more advanced, in the cloud, we're able to be more agile and have better intrusion detection, learn better patterns, bring in better capabilities with our security, with our privacy, and also with our certification levels that you mentioned as well, where on premises, yes, there is security. However, it is very slow to adjust and adapt, where we're able to do things much more quickly and be much more agile once the workflows are in Azure and in the cloud.
Great point. Jonathan, we talked about security. Can we talk about the same thing about what people really can expect in terms of scalability and performance? Because obviously that is equally as important for people coming from a mainframe environment.
Yeah, no, that's a great point. That's a great actually segue from that concept of being agile and moving to the cloud, is that there's so many more options now that we have. And Jim touched upon this earlier in terms of IMDS and how we're able to take advantage of that concept. So there's everything from scalable PaaS services, where simply by using the notion of a slider, we can change the amount of capacity, storage, and compute on workloads as needed. And as well as there's capacity in terms of different architectures. So two great examples are our Azure SQL Database hyperscale architecture, which has a scale out type architecture that allows us to have more storage and more compute and do fast processing in that architecture. As well as also on the open source side, we have on the Postgres database, we have a PaaS service, which is our Azure Postgres hyperscale, which gives us horizontal scale out for a Postgres database environment. And they're similar, even the name is hyperscale, there's similar concepts behind them. They're a little bit different architecture, but what they both do is provide scalability and for both storage and compute on these platforms. And so there's, by having those platforms as well as other layers, as well as on the application and compute side, we have things like AKS, Azure Kubernetes services, where you get a piece of code, piece of Java, piece of C# that's running in a container on these Kubernetes clusters. And you can have it defined where upfront you might know what your capacity and throughput is, and you can set that scale, or that we even have auto scaling options where, depending on if it hits a certain threshold, that you can have more nodes automatically instantiated and then running that code, running those containers on the fly. And so there's a lot of really fascinating options that we have, and those are just some initial examples. There's many more as well.
It's amazing. Being an old guy, I can feel safe saying it. It's not your grandfather's compute model anymore. The flexibility that exists is just astounding in Azure. Jonathan, I'd like to ask your opinion. How beneficial was it for the Air Force moving, you mentioned this before, to a PaaS database service in terms of being able to expand what they could do with AI and machine learning?
Yeah, that's a really great point. And so really, and Jim hit upon this earlier as well, but I'll build on what he said, is that one of the key things is that, the data is now in Azure SQL Database. And previously it was on, we were on a mainframe system in a hierarchical database architecture and structure. And now by being in a relational database in Azure on a PaaS database, we have a lot more opportunities where the data is much more accessible to other Azure services, of course, with security and with private endpoints and all the right regulations and security that should go into that is in place. But what's now an option to us, especially when it comes to ML, is that this data is now in a very good position to be used as training data for ML models. And in Azure, we have a very nice selection of ML possibilities. So we have everything from our Azure ML Studio and Toolkit, where you can write your own model and then use that data for training and create your own models and your own deployments, as well as we have what we call the Azure Cognitive Services, which are actually pre-baked ML AI models where the everything is already developed, and simply you just need to provide it your training data and as well as your input data, and it is a preset component that you're able to leverage. And so those are some of the options that are there, and these are all themselves Azure services that can then be easily plugged in to data now being in a PaaS database.
Makes sense. Perfect. Thank you. Jim, I'm going to switch back over to you if you don't mind. How important do you feel it is to have minimal change to the legacy applications and the source code when migrating for federal agencies when they're moving to Azure?
I'll give the perfect consulting answers. It depends. You know, it's in the Air Force, it was very important because number one is they couldn't retrain everybody. You got to realize that having a worldwide deployment of aircraft and management and repair of those aircraft, they don't really have time to train somebody on a new system. They always have to be running. And so in that case, and you know, you don't really want the screens to change. Okay, fine, the screens aren't, you know, the screens didn't change when, you know, at least on this particular application, but they've also previously got, at least the Air Force, previously went through a rewrite effort that didn't work. They tried to rewrite the application. They spent a lot of money doing that. It didn't work. So they really didn't want to change the code. So with the Air Force, it was very important not to have the code change. And so they were used to maintaining the COBOL code. They didn't want it to change, so it was important. You've got other customers that have different reliance on the source code that may want to, their system might be changing over where they're doing Java, C#, or any other, you know, a .NET language. That they want the code to actually change, and there's tools and capabilities for really transforming that if need be, if that's what the customer wants to do. So again, it comes down to it depends. The code doesn't have to change, and in this case, there was business rules that they had that they couldn't change a line of code. They didn't want to change anything, and so from that, it was very important. But you know, you're kind of having to look at is like, what are we trying to move towards? And they didn't want to have to bring in a bunch of new developers. They have, you know, probably millions of years of talent of COBOL in the code itself. Having looked, you know, yourself also having looked at it, it's like it was a lot of COBOL that made its way across, and so they did, you know. So I guess it comes down to it depends on the customer's requirements. But the good news is, oh, go ahead.
Yeah, I was just saying, and I mean, and just to build on that, I mean, Jim has a really good point. I mean, it does depend, and I think that's where, you know, up front, figuring out the pathway. Is it a rehost, a refactor, or a re-architecture? Kind of the three buckets we kind of see things in. It's kind of our point of view. And in this case, rehost made a lot of sense, both business and from technology. And so it worked out really well. There's lessons learned previously that we were able to leverage that lean towards rehost, but also looking at the full end-to-end, as Jim said, rehost makes sense. But what's nice is though, is that just because it's a rehost, it still runs in Azure. And we were able to leverage a lot of PaaS services, the database, Azure Data Factory, Azure Blob Storage. There's a lot of things that were around the rehost environment that even though it was COBOL code still running without a line of code change, there's also a lot of modern services that were also running at the same time. So it's kind of a hybrid in some ways. And so just because it's a rehost and code isn't changing, there's still a lot of opportunity to use modern Azure services. And that was done in this case, and we're doing with our other customers as well.
Yeah, and it certainly seems that, it's not necessarily a one and done. If an organization wants to do the classic rehost, take those savings and reinvest them and then come back and change to a more modern language, they can. It's part of a pathway, as you described. There is no one exact landing point for everybody. So providing that flexibility is important. Jonathan, I'd like to ask you something about disaster recovery. How important and what are some of the benefits of monitoring and disaster recovery when the applications have been moved to the cloud?
Yeah, no, that's a really important question, because that's one that comes up a lot. And that it's something where these legacy systems and mainframes, they do have a level of redundancy built into them on premises. However, they don't always have quite what the customer really does necessarily actually really want. And so we found that by moving these workloads into Azure, we can actually bring new capabilities in terms of disaster recovery, geographic redundancy, and auto failover that are net new capabilities that make, when disasters happen, when issues occur, it can actually be a more streamlined process and bring things that weren't possible. So it's a very important thing. It's always a key early conversation that we have. And in terms of a technical factor, in terms of going to the cloud and the capability that's unlocked, this is a common one where it's a something that we're able to easily and without a lot of complexity be able to bring to the table for that capability. So on those fronts, I mean, really, it's the notion of auto failover groups, which is a key feature in Azure SQL database, the PaaS database, where you can have in one region your database running, and then in the case that there is either a failure of some sort, various on the database level, you can have an automatic failover to another copy in another Azure region, and the same endpoint. It'll be the same endpoint that you use, so that way your application layer doesn't have to change. It will simply redirect to that new environment with a replica of the data. So there are things like that are unlocked with moving into Azure. And then beyond that is also the geo-replication. So there's various services. There's Azure Database, there's Azure Blob Storage, and other ones where the data is not only replicated multiple times within the Azure region, but then you can choose to have it replicated outside the Azure region into another Azure region, and it gives you this really great level of redundancy. And so that way you have that. And one more quick item to mention on this is with IMDS was one of the other key capabilities that was unlocked was the ability to do fast restores of databases. So be able to spin up a new environment, do a restore, and have that environment available was a very key thing. And so that's something where on premises, in order to provision a new environment, a new LPAR on the mainframe to replicate data, all that is time, it's expensive, it takes cost and MIPS and all these aspects, where in the cloud, it's faster, and it can also be cost savings as well.
I can't tell you the number of customers or companies I've talked to over the years who say we've never really had a successful DR test. For whatever reason, we ran out of time, we ran out of money, we ran out of resource, and they never really proved that it would work. Then when they go to Azure, they're amazed at how easy it can be.
Absolutely.
Jim, I'd like to jump back again to something you mentioned before about DevOps. From your perspective, what are the benefits to implementing DevOps and agile methodologies, especially for federal agencies?
Well, historically, federal agencies have kind of followed waterfall approach, and there's a lot of project management that has gone into kind of trying to move to more of an agile type DevOps approach. One of the, a couple of things that was, I guess, an impediment to that was the systems themselves and a couple, a couple other items that kind of, but by moving into the cloud, it enabled at least this, in the Air Force, where they moved from model where they're now trying to do continuous integration, continuous delivery. They're trying to fail fast, just like one thing that Jonathan just brought up a second ago about the ability to duplicate the system. So if you need to be able to take what is in production, run a script, have it running over, you might, lower the amount of for testing, but say, okay, let's take a picture of production as of right this minute, and let's do a snapshot copy over here, and then we'll run against that snapshot copy, and we'll only give it 2 CPUs, and we'll throw a lot of workload at it or something like that. So it allows them to fail fast and start adopting some of these more agile practices where they can now divide things into smaller teams. They can now, go through and start, hammering different things out, dividing workload, because before they had to coordinate when their workload or when their testing was being done. And now these individual teams have their own environment that they can base off the production code. And then also it enables some different tools like DevOps and things like that are part of the cloud, where you can check in your changes and you have full access to tools such as debuggers and things like that you really were kind of limited in your capabilities previously.
There's
tons more.
Yeah, there's tons more. Yeah, exactly. And actually, just to add a few more. I mean, to Jim's point about the small teams and the ability to do improvements is branch management. And so by having a modern DevOps environment and be able to have access to the modern source control, is that be able to have a modern branching strategy where you can have your main production branch, but also be doing your improvements, do testing, try out things in other branches, and have your own Azure separate environment for those branches, do your experimentation, hammer things out, and then when you're ready, merge that back into your main line. All these things are now possible in Azure DevOps, and DevOps in general is the capability for doing that. But then, of course, using tools like Azure DevOps, Visual Studio, and other tools like that brings all that together into a nice tool set.
Also the automated deployment, the automated deployment tools.
Absolutely.
They didn't have access to those previously, and then I think when we were showing that to them, they were like, "Oh, this is great! Oh, I wish I would have had this."
Absolutely.
Especially debuggers.
Yeah. From the IMDS perspective, obviously it was a very successful project, but there were lessons learned. There were things that had to be accounted for. I think this is going to be really important to our listening audience. And I'd like to ask this of both of you. From an architectural viewpoint, what are some of the biggest challenges that agencies need to be aware of as they think about a migration to Azure?
I guess initially would be the first thing that kind of jumps to mind is testing, is the ability to generate or have tools to generate, look at the load testing environment, or the ability to generate synthetic load against your environment. So if you have, let's say, users, and you have the ability for those users to hit the application, and you've recorded that, and then you can spawn off additional clients, let's say in the cloud, worker clients, that would now hammer your system itself. And the ability for running those, the ability the need for that is first generating synthetic load, and instead of just having what you think is a load,
Mhm.
you want it to try and match as closely as possible to what the production workload looks like. So you definitely want to spend as much time as you can initially doing that. I'd say that was one of the bigger challenges, is what was originally seen as a load test really wasn't a load test, and it had to be generated on the fly. Just running reports, good example, is just running reports over and over and over isn't a really good load test on the system. It's good for if everything you're running is reports, but that's not really the case. You're
Right.
running reports and having to balance reports with transactional workload. So it's just even more important, I think, to have the transactional workload, because reports, anybody can run reports. You can go in and easily do that. The challenge comes in is when the users in the transactional volume or mimicking that transactions of the user activity, and then being able to run the reports on it. So it's well worth spending time up front thinking about how you would generate the synthetic load, and would that synthetic workload look like our system? Because our goal in this, another thing is on Jonathan's and our side, our goal is to break Azure. Is if we can break Azure, great, because if we can break it, then by throwing additional workload at it, by synthetically generating huge amounts of workload, we want to see what it looks like when it breaks beforehand. This is before it goes to production or anything like that. Just like what we're doing, you want to break your application and see what happens when, let's say, you hit the scale limit, or what happens when you hit the memory limit, or whatever limit that you have, and how does it behave? And then you take that, and now that you know how it behaves, you can start putting some things in place to look. And this would be another thing looking up front, is if it breaks, what does it look like leading up to that break? Do we get any warnings? And now we can have alerts, and we can have all sorts of different pre-warnings before we hit a failure. So thinking about those and realizing again, it gets back to the synthetic load testing, is the ability to hammer your application with as big a hammer as you can hit it with, to see what happens when the application hits that, and then being able to document that knowledge and learn it before it hits it in production. The second thing is, if you do hit any activity like that, you want to go back and do kind of root cause analysis and take a look and see what happens, so that you can also, you might not have tested, or it's a real world thing, like a denial of service attack, or whatever that you were hitting. You just want to make sure that you're constantly learning and constantly bringing in those messages and updating and evolving your alerting, so that you're taking these lessons that are learned and alerting on them, and looking at those other types of things. I guess another one would be having an architecture that scales horizontally, vertically. Just where can you scale? Jonathan had brought up before the hyperscale database architecture that can, there's different levels of scale there. This was actually a classic kind of 3-tier application architecture. Well, where can the application scale itself? There was a web server that's on the front end, the ability to take that and put that into a cloud-based web server, so that it can dynamically handle the scale if the web activity goes up or goes down. So it's kind of the auto scale capabilities that enable some of the scalable architecture.
It sure seems to me that it's the difference in being proactive and reactive. As you say, be prepared to test it, be prepared to put stress on it, and to measure and monitor what happens, so that you're not surprised when something happens. So that plan, that methodology and approach is really critical as you move forward. I absolutely agree.
Yeah, one other thing that's kind of that you want to take into account is you've got the users. In our case, in the U.S. Air Force's case, users are coming in from everywhere, and so we can throw load, we can do everything in the cloud, but you want to make sure that you pay special attention to the network of the data from the users that are coming in, because a good example is Air Force. Well, this is coming in from overseas. What if it's coming in from overseas? It's probably going to be hitting a satellite. So you want to make sure that you're testing a high latency environment, so that you're not all of a sudden, hey, it's running real fast in everything in the cloud and we can handle with this scale. But how are you doing with a 1.5 seconds latency of a cloud that's coming in? Now, there are tools that you can use and you can test for that, but just make sure that you do that from a lessons learned perspective.
Absolutely makes sense.
Yep.
Well, guys, it looks like we're at the end of our time. I wanted to thank you both for taking the time to be here. And if people who are listening wanted to learn more about what you and your teams does, how should they best reach out to you?
Jonathan, I'll defer to you on that one.
All right, sounds good. Yeah, thanks, Walter. Thanks, Jim. So there's a few ways to reach out to us. One great way is that we have some number of artifacts that are published on the Azure Architecture Center, which there has links to an email alias that comes into our team's inbox collectively. So you can go to aka.ms/refarch, REFARCH. And so that will go to the reference architecture library. And then from there, you can navigate to the mainframe and mid-range category. And there you'll see our collection of reference architectures. And as well as then those will link off to other white papers and artifacts that we publish as well. And then we have an email alias as well that is available on those, that if there's interest from partners, customers who want to work with us, have questions and can require help, that there will be an email alias there as well. It is legacy #2 Azure at Microsoft.com, but it'll be on that reference architecture site.
Perfect. Jim and Jonathan, again, thank you both so much for taking the time to join us today. This was an extremely informative and helpful session, and I'm sure the people listening have thoroughly enjoyed listening to you on this. Thanks so much, guys.
Yeah, thanks for having us, Walter.
Thank you.
And for everyone in the audience, thank you for taking the time out of your busy day to join this latest edition of the Walter's World podcast series. If you want to see some of the upcoming sessions that we have planned, or if you want to learn more about the Air Force project, please take a look at www.astadia.com. So again, everyone, thank you very much. And until next time, we'll see you then. Thank you.